Okay, so we repeat the same example with the input x of t. So we have the input x of t. Okay, now it will be the controller form. So talking about the second one, the controller form. Okay, for the controller form, so we're using the Laplace transform. Laplace transform. Calling the LP with zero initial condition. With zero initial condition, so let's say we have the y 1, 2, 3 when we transform. So this one will be the s cube ys. So this one we have the 0, 0, and then y double prime transform to s squared ys. Also with the 0, 0, y prime. So you have the s ys plus the 0 y transform into ys, and then x transform into x of s. Okay, so these are the things that you should remember, that we are going to use only this one. Okay, the transform. So what we have here, y double prime, then went to Laplace transform. This is question, Laplace transform both sides. So you have the s cube ys s squared ys plus s ys plus ys is equal to x of s.
Missing constant, A1, A2.
Okay, so plus a1 plus a2 a3 plus a3. Okay, so you can remove this one s cube, a1 s squared plus a2s plus a3 ys is equal to x of s, ys over x of s, 1 over s cube, a1 s squared plus a2s plus a3. So this one will be equal to bs over as. Okay, so our as is equal to s cube, a1s squared plus a2s plus a3, and the bs is equal to 1. Okay, so we will be using dummy m. So we'll be using introduce dummy m. Where y x of s is equal to as ms, and the ys is equal to bs ms, and the m is actually, if you observe that ms is actually x of s over as. So what we have, ys is equal to bs over as multiplied by xs. So what we did is this one will be equal to ms. So we have the ms, capital M. So ms is xs over as. Okay, so the student has to remember that this is the only thing that is important. This equation, x of s is equal to s ms, ys equal to bs ms. So that is the most important thing. Okay, then to remove this one. Okay, so for the x of s is equal to as ms is equal to s cube s squared plus A2s plus A3ms. So this one x of s is actually equal to s cubed ms a1s squared ms plus a2s ms a3 ms, and to perform the inverse Laplace transform, then this will be x of t m triple prime t plus a1 m double prime t plus a2 m prime t plus a3 mt. Okay, then rearrange equation. When you rearrange equation, then m triple prime will be equal to x minus a1 m double prime minus a2 m prime minus a3 m. So this one will be your first equation. Then ys, the output will be dvs ms, and this one is equal to ms because your bs is equal to 1. Then inverse Laplace transform, y is equal to m will be the second equation. Okay, now we draw the simulation diagram based on the first one. So you observe that the first one we have the m 1, 2, 3 into integrate m1, 2 integrate m prime integrate m, and this one is given by the equation, and the first one we have the x minus a1 minus a2 minus a3. Okay, so this one is basically the first equation, and the second equation m is equal to 1. So this one is the second equation. So you observe that this one is the controller form, which also equal to the direct form if input is only x of t without derivative terms. Okay, so this condition is only valid if the input is only s of t without derivative term. Okay, so this is the first example where we have the input is only the x. Okay, let's say we change the input to additional, the same thing as we had before, b naught x t plus b1 x prime plus b2 x double prime t. Okay, so the same thing that we're going to do is perform the Laplace transform of such. Laplace transform of side of dVE. Okay, so you have the s cubed plus a1 s squared plus the a2s plus a3 ys is equal to b naught plus b1s plus the b2 s squared x of s. Okay, so this is the transform where you observe that this one will be the as and this one will be the bs. Okay, so this is the simplified way. Okay, then you observe the formula that was given. X of S is equal to AS M or MS. So you have S cubed plus A1 S squared, A2 S plus A3 multiplied by DMS. And we transform into time domain. So this one will be the inverse Laplace transform. X will be equal to M1, 2, 3 plus A1 M double prime, A2 M prime plus A3 M. And the M double prime will be the X minus A1 M double prime minus A2 M prime minus A3 M. So the first equation, so this one is the same thing as we have when the input is x naught. Okay, then y of s is equal to bs ms. So you have the b, which is the b naught, b1s plus b2s squared multiplied by the ms. Okay, then the inverse Laplace transform, then you get yt, y. Okay, yt, which is equal to b naught m nt plus d1 m prime t plus d2 and double prime t. So this one will be the second equation. Okay, so we have some modification done to the previous diagram. So we already have this. Okay, so these are the previous one. So the output will be the M multiplied by dV naught. So you have V naught. So the summing to produce the Y. V naught M prime, which is the V1. And then M double prime will be the V2. Okay, so this is the controller form that we obtain. Okay, so that concludes the controller form simulation diagram. Okay, stop dulu.